Hey, this is OXDF, and today I'm looking at Advent of Code 2022, Day 13, Distress Signal. So we are going to get a list of pairs of packets. So these are packets. And packets are going to have integers or other lists of integers or lists of integers, right? So each recursive. And I need to compare each pair of packets and figure out if they're in the right order. And they give us some rules down here. So if both values are integers, the lower integer should come first. Um, if the lower one's first, then you're good. If the higher one comes next, you're bad. And if they're the same, you can move to the next item. If both values are list, you compare the first value. You compare the values of the lists, and if they're in the right order, same thing. Then it's good. If one list runs out before the other, the left list should run out first. So for them to be in the right order, the one that's first should run out first. And if only one of them is an integer, you can just convert that integer into a list by like turning 2 into list of 2 and then compare them. And so using those rules, we compare. So for example, here we compare 1 and 1, they're good. 1 and 1, we're good. 3 and 5, 3 is less, so we're correct. Here we compare our list of 1 with our list of 1, which means then comparing 1 to 1. Then both lists are done at the same time, so we move to the next one. Now we compare our list of 2, 3, 4 to 4. We'll turn 4 into a list, and then we'll compare the first items, and 2 is less than 4, so we're good, still in the right order. Here we compare 9 to 8 sevenths to this. When we compare 9 to this, well, it's integer versus list, so we compare list of 9 to this. We compare 9 to 8, wrong order, because 8 should be before 9. Here, we'll start by the first item is list of 4, 4, and list of 4, 4. So those will be the same. Then we compare 4 and 4, 4 and 4, and then this list runs out first. So we're in the right order because this one's less than this one. And here's the same thing. We compare these, but this time this side runs out first, so we're in the wrong order. So I think you get it. Let's go ahead and jump over to do some coding. So we can use the genday script here for day 13 to build myself a stub and pull the input. And I've got a link to this in the repo in the show notes, as well as you can check out my day 1 video. I'll give it a little bit more love. Let's start with looking at the input. And so it's a lot more pairs. Looks like we have 200 something pairs. They're longer. Nothing too exciting. We're gonna change here. We're gonna read this in, and we will strip it to make sure we get rid of the new lines at the end. And then, so we need to think about like how we're gonna approach this. So the first thing I want to do is get these into pairs. Excuse me. So we can say, let's loop over the pairs. So we can say like for pair. Oh, we're gonna need to. One thing I didn't say in the description is what we're gonna do is we're gonna loop through all the pairs, and for each one that's in the right order, we're going to add its index starting at 1. So the first pair, the second pair, in this case, the first, second, fourth, and sixth were right, so we get 13. So we're gonna need that index. So we'll say for I comma pair in. Let's not call this lines. Let's call this data. Data.split, a double new line. So now we'll have a pair, and now we can say P1, P2 equals pair.split new lines. And now what we really want is to bring this in as a list, as Python lists, lists of lists and lists of integers. And the easiest way to do this is to apply the eval function. If we take this as a string, I think this one will be a little simpler. If I take this, if I come here and I do Python, and I say eval, paste that. If I paste that eval that string, I get back a this is a list with a list and an integer, and so it's all there already. You never want to run eval on user supplied code. That can be very dangerous. That basically gives them code execution. But we trust all the data here. We've skimmed through it. It looks like it's all integers and lists, so we should be fine. So what we're actually going to do here is we're going to use the map function to apply eval to each item in the pair, and then we'll just need to get this into a list so that I can split into P1 and P2. And so that'll give us both objects. We can actually test this. Let's try P1, P2. Get out of here. Python day13 input.text. And let's see. Too many values expected to. Oh, we want to enumerate. And what enumerates is going to do is for each item, it's going to give me the index and the item. Cool. So we got, nothing, just a quick skim. All I can tell is it's giving me what looks like reasonable Python objects. So we can get rid of that. Now, what do we want to actually do here? We're going to say if compare, which we haven't written yet, P1, P2 equals, say, -1, because we're going to do, this compare function is going to return -1 if P1 is less, 0 if they're equal, and 1 if P2 is less. So we will do, if that's true, we'll do part1 plus equals and because I is going to be 0 index, so we actually need to do I plus 1. So we can come up here and say part1 equals 0, and we can get rid of this line. And now we just got to write the compare function, which is really the meat of the whole problem, right? But with 3. So def compare P1, P2, not P3, P2. And what do we want this to do? So we care about what they are. So kind of our base case is if is instance is the function we're going to use to figure out what this is. So P1 int and is instance P2 int. So if they're both ints, this is very simple. If P1 is less than P2, return -1. If P1 equals P2, return 0, and otherwise we're going to return 1. That's easy enough, right? Now we have the case, there's 3 other cases, right? P1's an integer, so they're both lists. P1's an int or P2's an int. And the good news is, at this point, I can sort of just say, if one of them is a list and the other one's an int, I'm just going to convert that one to a list and then I'll have 2 lists, right? So I can say if is instance P1 comma int. At this point, I know they're not both ints. I can just say P1 equals P1. And if is instance P2 int, I can say P2 equals P2, like that. So now I'm guaranteed to have 2 lists. That's what I want to do. I want to say we'll say x1 comma x2 in zip P1 P2. So I'm basically going to take them pairs at a time. Give me the first from P1 and first from P1 and the first from P2. Give me the next one from each list. That'll be x1 and x2. And so I can loop through those. And I can say res equals compare x1 comma x2. And the reason I got to do a res here, like I got to actually store this because I'm going to have to do different things, right? So if res equals 0, so if there's 0, I don't want to return anything. I want to actually just continue to the next item. So I'll literally just put continue here, and that'll break and get the next 2 items here. Now I can say return res. And so what works out cool here is what's going to happen is as soon as I get a place where they're not equal, I'm going to return. Perfect. That's what I want. If they're equal and let's say that means eventually we'll find a place they're not equal, or they'll get to the end of the list, in which case they will still continue here, realize there's nothing more, and break out. So now I got to come down here and say, well, now I've gotten to this point. That means that both lists were entirely equal. And so zip, this is where it's important to know how zip works. Zip is going to take them up to the length of the shortest. And so at this point, basically that means whichever one is shorter, we've been equal up to the length of the shortest list. But so now we return based on the shortest list. So like if len P1 is less than len P2, that means we want to return -1. If len P2 is less than len P1, we'll return 1. And now if neither of those things are true, that means the lists are of equal length, we'll return 0. And so now we've got a compare function. So if this works, we've solved it. Give it a try. We got 5366 over here. Nice. All right. We'll probably speed up the video here while I read part 2. All right. So in part 2, we're going to have to sort all the packets, and we're going to disregard the blank lines. And we're going to add 2 additional packets. So the list 2, list 6. Then we're going to sort them all. So like the example would look like this. And then we're going to find the index of the 2 and the 6, multiply that together, and that's our result. Okay, so I think our compare function has set us up really nicely for this. So what we're going to do here, let's see. We need to say lines equals line for line in data dot split. And then we want to make sure it's not new line. So I think we can just do if line. So if we run this, let's do this. We'll run this with a dash I. And now we should be able to say lines. Looks good. I don't see any blank ones in there. Yeah, so that looks good. So I think we're happy with that. Now we actually just wanted, so we also need to add 2 more. So we'll say lines dot append, and this will be like that. Actually, you know what I should do? We'll test this and make sure it works, but I think it's lines dot extend. I always screw these up. And now we take the list and we add on 2 like that and 6 like that. And because it's extend, I think it means adds these. I'm hoping it'll add both of those to the list. And we will check this right now because we don't want to go any further if we have done that wrong. Yeah, so look, the oh, we need to eval the line because right now they're strings, but otherwise it's looking good. So we will do eval. Try that. And so perfect. We've got these things, and then this item right here ends, and the next item is our 2, and then our 6. So we're good here. So now we're going to say, in fact, let's just do what the best idea here is. We could do this all at once. Okay. We'll say sorted lines equals sorted lines key equals compare. I think I can do it just like this. Let's try that and see what happens. It might throw an error. We might need to make a lambda function. Missing one requirement. Okay, so we'll say lambda p1 p2 compare p1 p2 like that. The p though. Think that'll work. Lambda missing 1. Does it take? Let's see real quick. Python sorted. Let's take a look and see if we can figure out what this. Okay. So ignoring the slow Googling here, this Python sorting page is really what I want to be. And basically, if I've got a comparison function, like compare AB, which returns negative for less than, 0 for equal, and 5, that's exactly what I have. I want to use this functools compare to key wrapper around it. So we're going to come here and we're going to do, we'll come from functools import compare to key. Beautiful. And then we come down here and we say key equals, I think we can just do compare to key compare. for that. Let's give that a try. And we run this, and do we have sorted lines? Hard to say for sure, but we have maybe something. So now we can do, I guess we'll just do part2 equals 1 for line in sorted. Oh, in fact, why don't we just do that? If, oh, and we don't want line, we want I comma line in enumerate there. If line in 2, 6. If it's one of those two things, we're going to multiply part2 times equals I plus 1. And we can get rid of this, and we can save this, and we can give it a roll. We got a number, 23391. Let's see if we got it. I hope we do, because this seems like it'll be a real pain to troubleshoot. Yes. All right. So we really benefited in part 2, other than just having to find this key to compare function. We really had almost no work to do in part 2, so that's pretty satisfying. Basically, this compare function is what helped us out. So an alternative view, we could have gone through and actually made like an object for a packet, I think they call it, and then had a compare function, like a dunder compare function, and then we could literally just do less than and equal signs. That might have been kind of neat to look at, but it's worked pretty well. So thanks for hanging out with me today, and I'll be back tomorrow. Thanks, bye.